Hi, welcome to your teacher tutorial for your microbit. In your pack you'll get the standard microbit and a battery pack which is easy to connect. You've got LEDs and pins ready to start coding with. Hopefully this tutorial gives you some ideas for some lessons. Have fun! In our first lesson you'll need to model how to get onto the microbit website. Click Let's Code Again, and then open a new project. To delete code, drag the blocks to the left. To create an algorithm, drag the blocks to the right. For our basic code, we need to start with a start block, and then we've used a show string block to display some text. We're going to introduce a pause, and then use another piece of text. After that, we're going to have some fun with the LEDs. You can design an LED pattern, or you can choose from one of the pre-selected options. As you can see, when your code is not attached to a start block, it goes grey. Once you're happy with your file, you can save your work, attach your microbit via the USB to your laptop, and download your hex file. Once it's downloaded, you need to drag it across to your microbit through your computer, and then the code will be on your microbit until you download a new piece of code. Don't forget to include your battery pack, otherwise it won't work. In our second lesson, we'll be consolidating our learning by creating an animation. I've chosen to create an animation by using two different LED patterns and putting them in a forever loop, so it appears to be flashing with a square. Your children can choose to do anything they like as long as it's an animation that is appropriate. Again, you'll need to save your work, download your hex file, and drag this onto your microbit before it works. In our third lesson, we'll be creating a step counter, which we're going to use a forever loop and a start loop. First we'll need a show number and a pause, then we'll create our variable steps, which we can set to 0 on start, and change when we shake the microbit. We can then look at the preview bar and shake the microbit to see if it worked before downloading it. You could then test this out by attaching it to yourself via elastic bands and going for a run. In our fourth lesson, we're going to use the microbit as an output device. When we press an apple, which is attached by a crocodile clip, we'd like it to say A. When we press the orange, we'd like it to say O, and when we press the banana, we'd like it to say B. To do that, we're going to use 3 different pins, pin 0, 1 and 2. We're going to code them to identify when the circuit is complete. You could duplicate the code by right-clicking and pressing duplicate, or you could remake the code in pin 1 and pin 2. You'll then need to download your code onto your microbit. To set up, you will need 4 crocodile clips. Attach these to pin 0, 1 and 2, the pins you've just coded for, and you'll need one attached to the ground port. You will then attach these into the fruit. I've tried to colour code them to make it slightly easier. Then hold the ground to complete the circuit and touch the fruit. Hopefully you'll see the correct letter displayed on the microbit. In our fifth lesson, we're going to create an egg and spoon race. To do this, we'll need to think about the LED screen, and we're going to use the accelerometer to detect movement. If we tip it left, we'd like the LED on the screen to move left. If we tip it right, we'd like the LED on the screen to move right. This is quite a complex code, so I would consider showing children this code and getting them to work backwards to unpick why this works. Again, you'll need to add a variable. This time you'll have 4, x, y, accelerometer x and accelerometer y. We will then use a if, true, else, if block, which is logic based. So we can say if it tilts left, then move left. If it tilts right, then move right. then need to say where we would like the LED to first appear on the start. To do this, we're going to use coordinates again. 2 by 2 puts us in the centre of the square. Once you're happy, you can then download your hex file and drag it onto your microbit to see if it works. Let's have a look. And it works! In addition to the microbit, we also have unplugged blocks which further develop logical reasoning. Unplugged activities are when it's away from the computer, so are with paper. Let's have a closer look. This supports children with creating and debugging their algorithms to develop their logical reasoning skills. Thank you for watching.